Hello everyone, and welcome to Screenwalks. My name is Marco De Mutis. I'm digital curator at Fotomuseum Winterthur in Switzerland, and together with John Uriarte at the Photographers Gallery in London, we have created this collaborative program of fortnightly live-streamed events. Through Screenwalks, we are interested in investigating the changing role of the photographic image in its networked and digital forms. Each event is led by an artist, researcher, or a curator who takes the audience to the spaces where their core practices take place. Screenwalks can be a live performance, a peek behind the scene of an artwork, or a guided tour among other possible formats, a guided tour inside the computer or a machine tonight. We have hosted more than 60 Screenwalks already so far, and you can find video recordings of each one of them on our website and YouTube channel. Also, we are just back from our very first Screenwalks weekend at the Photographers Gallery in London, where we had 3 great days of events with artist performances and guided tours off the screen. And we'd like to thank all of those who made it out to join us, and also, of course, all the artists who accompanied us in this fantastic event. Make sure to join the next one, hopefully next year somewhere, we'll see. But finally, now back in Zoom, and please remember that if you have found Screenwalks useful for your professional personal interests, do consider subscribing to Folders. For €7, you'll support the program and its artists, and also get your personalized folder on folders.screenwalks.com. There you'll receive files and extra content from the artists and researchers of Screenwalks. Now, some housekeeping information. Your microphone should be muted to avoid noise disturbances. If it's still on, please mute it now. We are recording and will be archiving this event. Please use the public chat to ask questions, or feel free to send a private message to John or to me.
And hello from my side too. I'm John Uriarte, curator of Screenwalks with the Photographers Gallery. Today, as Marco mentioned, we will be looking into machine vision, machine learning, and other ideas around images and machines with Estampa. Estampa is a collective of programmers, filmmakers, and researchers based in Barcelona, in Spain, who over the last few years have created several projects experimenting with different audiovisual and digital techniques. They've used a wide range of technologies within the so-called artificial intelligence field, questioning its social, political, and material impact. Research projects, installations, performances, books, or films are among the different formats they've used to explore how these technologies are currently reshaping the role of the image in contemporary society, questioning notions related to surveillance, automation, science fiction, or ecology, among others. For the Screenwalk today, they've been very generous to open and show us the very machine they use for many of their projects. Understanding how machine learning systems and material process generate images is one of the most important challenges of these technologies, especially nowadays when most of the interaction with them is limited to writing a prompt and clicking submit, shadowing further a much needed access and transparency. We are very happy and excited because Estampa will offer us today a very interesting opportunity to understand the inner workings of the machine and some of those processes locally, rather than employing online platforms. It will also be a journey through time and recent AI history, as the time frame of Estampa's projects covers 6 years, which in AI is like a century, we'll say, in which several techniques have changed and evolved in the field. During the walk, old and recent neural networks will be used to generate images or text, and a computer vision tool will search through 600,000 images stored on their hard drive, experimenting with randomness and reflecting up on the medium. As previously mentioned, Estampa is a collective of programmers, filmmakers, and researchers, Pau, Daniel, Marc, Roque, and Marcel, whose practice is based on a critical and archaeological approach to audiovisual and digital technologies. Since 2017, they've developed a significant body of work focused on the uses and ideologies of AI, an interest that began with a project programmatically titled Debat Pupil, Critical Pedagogy for Artificial Intelligences in 2017 and 18. This has been followed by more than 20 research projects, installations, performances, and so on, that we are really looking forward to learn more about today. So Estampa, we are very happy to have you with us today. The screen is yours.
Okay, Oh, sorry. No, nothing with it. Okay, sorry. So many thanks for inviting us. As John said, we are 5 in the collective, and I'm Daniel.
I'm Pau.
I'm Mark. And we will be here. We have a script for the screen walk. We have a path for our walk, but it's open to your interventions, and I mean anything you want to ask, or if you see something you want to see close up, if you see a flower, a tree, and you want to ask to stop there in our walk, we can stop there. And yeah, we will explain a bit what we are going to do. We are going to share screen now.
We're already sharing the screen.
You're already sharing? Okay, sorry. We have 2 computers and we have 2 computers and 4 screens. So it's not bad for a screen walk. Okay, so this is our website. And as John said, we are based in Barcelona, and we have done several projects. And we started working with AI with this project entitled the Bat Popul, Critical Pedagogy for Artificial Intelligence. And as John said, it's a title that we like to say that it's kind of programmatical for us, because it's using a metaphor of the technology and of the industry, this metaphor of learning, and appropriating this metaphor and championing somehow a bad pupil, a pupil that it's against the more normative side of artificial intelligence. This was our first project in 2017, 2019, and from this project on, quite a lot of our projects involve artificial intelligence tools. We always said that we work with tools and ideologies of artificial intelligence. That's what we are researching and what our work focuses on. And most of our projects from this project on use somehow artificial intelligence. Some involve computer vision, some involve text generation, and some involve image generation. And yeah, on our website, we have a lot of information about each project.
Yeah.
So maybe we are stop sharing now the screen, and we are going to show you what where we are going to be, what we are going to see.
Yep.
No, because today what we are going to do is to share and to walk through a concrete computer. It's the computer that we use for our artificial intelligence project. And this computer that Pau is
Trying to show.
Trying to show you, yeah. So we will be exploring this computer. And it has a special GPU,
right?
And it was the first thing that we did when we started working with AI was to buy a GPU, because we wanted to work locally, and we wanted to have the tools to work with them. So a lot of networks then were open source and you could install in the computer. At that time was more kind of a necessity, but it's also our kind of approach to things. We like to do a kind of do-it-yourself approach. And today that there are artificial intelligence services that you were referring before, no, that you can write a prompt and have image. So, I mean, in the current landscape, this do-it-yourself approach, maybe it's more, has more meanings than before. And also in this computer, the other thing that we have is that something that we did recently, that is a power consumption. We are monitoring the power consumption of our computer for artificial intelligence. And yeah, and this is related to this, of course, this ecological problem and this ecological point of view about all digital technologies, but particularly about how much they escalate these technologies. So this is a a project that we have that we are monitoring the consumption of this computer.
Yeah, actually, every hour it takes a picture of the counter, and actually it's online, so you can check it if you want. You can see here all the files. Now, this is the amount of kilowatts hour that it has consumed since it was installed. And we will check it in 1 hour to see how much energy we have consumed during this screen walk.
And when we show this as a work, we have this as an installation recently, and there was a table of equivalences. How much does it take to generate an image in Stable Diffusion? And you can relate it to other kind of consumption. And of course, here, what is important is that it's so easily escalated with digital tools. So it's not what the cost of generating one image, but that when you use this kind of services, what these services ask you to do is to generate a lot of images. So the problem is how this escalates. In a sense, also, we will be looking to our computer, and with that, we will have kind of a model of how artificial intelligence work. So in a sense, also, we have like a small peek, and we can imagine how more industrial tools work. Okay. So that will be more or less an introduction on what we are going to do. We are used to speaking in streaming, but it's always a bit strange not seeing faces and all that. So yeah, we are going to start.
Yeah, okay.
Okay.
This computer, it has 3 internal hard drives and 3 external hard drives. So it has a lot of data in it. Mainly, we are going to use, okay, sorry, Danny, thank you.
Yeah.
We are going to browse mainly the one called data.
Okay.
It's the name, it's data in Catalan, but in English it should be data. We also have the main hard drive where we have all the code for these neural networks that we use, the tools that we have been speaking. But here it's only or mainly code, so just the tool, but not the data set or the trainings that we do. So for this screen walk, what we do is browse the data hard drive sorted chronologically. Okay, so you can see here all the folders inside the hard drive, and they are sorted by the modified date. Okay, so we can see that the first folder is from 2017, sorry. Some folders have the modified date change because sometimes later on we add something and it changes, but mainly it's quite sorted. So it's going to help us explain our history. Okay, so the first folder that we can see here, it's called Intraphase. Intraphase was the first tool, maybe that used artificial intelligence that we became interested in. It was for a previous project about the phase.
Yeah, it was a video essay on the history of the phase, on the history of analysis of the phase. And it started in the 15th century and it ended in computer vision tools.
Okay, so we can see here, for instance, an example.
These are tests.
Yeah,
What no,
yeah,
okay.
no, it was
Okay. What we will show, maybe it's okay, it's okay. Yeah. No, pero aquí no está bien.
Okay.
Sí, sí, señálate.
Okay.
What we will show you mainly is tests. We won't see really like final images of projects. We are browsing through our archive in the most literal sense of archive. So the things that you do when you do your project. Yeah. And we like to work a bit with this idea, the idea of collage and submitting inputs that are not that common, maybe.
Yeah.
And here you can see also something that started to interest us, which is the when the tool doesn't work properly, when it doesn't detect the phase, but detects a phase in another place of the phase, or even in the text. Sometimes there was a phase in the text. I don't know if you saw it. And this was kind of an initial moment for us because sí, espera, allá, ¿no? In the bad pupil, this was kind of yeah, a beginning moment for us. He has in the bad pupil, we have this section about first experiments. And this was an input. We used that very well-known taxi driver scene when the character played by Robert De Niro is saying, "Are you talking to me?" and all that. And we think that the tool worked properly, but it was this misidentification that we thought was very, very interesting, because it was like, we always said like that, we tend to use it as a proposition instead of a mistake. It was like if the tool was saying, here the face, here the psychology is on the gun, it's not on the character. So this kind of mistakes and kind of re-signify somehow the tool is something that we really like. And that's why it was kind of a beginning moment for us in working with these technologies. No, anem al ImageNet, no? Bueno, pues te podemos enseñar. Sorry, we speak in Catalan between us, and sometimes we are murmuring things, but it's nothing bad what we are murmuring.
The next folder that we have on the hard drive, it's called ImageNet, as they have been told before. We have some captures of the CNETs, the different categories that were in the ImageNet dataset. So for instance, we have bad person as a category. I know there have been some very good projects in the photographers gallery using ImageNet. There was I don't know what it was called. It was shown during 2 months in the
ImageNet wall.
In the ImageNet wall.
Maleve, no, John?
Yeah, that was a project by Nicolas Maleve, who did his PhD research with the Photographers Gallery and also with the Center of the Study of the Network Image, and showed the whole dataset of ImageNet on the media wall.
Okay.
So, wrongdoer, offender, counter-terrorist, demigod, Superman, everything. So this got interested in this artificial intelligence area and how these tools are constructed or trained or how they learn. So
yeah, we were interested in that because we started using computer vision tool called YOLO 9000. And the labels that this tool used were a bit puzzling for us. We submitted an image and it says like worker. So we started to think why it says worker. And that this also is also a beginning moment for us that say why this works like this. And does this mean that there's a data set that somebody has been looking for images and labeling workers inside an image? That's why we ended in ImageNet, and as everybody that ended in ImageNet, except maybe ImageNet people, we don't know why, we were a bit, we were very surprised to see all these kind of categories, which some are really funny, no? Like Wagnerian, having this in a computer vision tool, or wine lover. But some like bad person or others are quite scary. And also maybe it's interesting that we started working with this in 2017, and maybe more things were open at that time, so you could check more things, and there were also, you can somehow, it's like if it was symptomatic of what is the thinking behind artificial intelligence or computer vision. Yeah, on this first moment. And now these sign sets are removed because it was this project by Kate Crawford and Trevor Plugland that ImageNet Roulette. So now it's also an archive of what was ImageNet. That's why it's interesting also that we have this in our computer, as many other people has captures or even the whole ImageNet. Capture?
No.
Okay.
Okay. Now we want to take a picture of you, or actually record a video of you, because later on we will process with using different computer vision tools. So if you don't mind being recorded for something like 10 seconds, actually the session is being recorded, so it's almost the same. The difference is that now you have to turn on your webcam if you don't mind. If you mind, it's not a problem. So we are going to stop sharing the screen and go into gallery view. So if you can turn on your screen, we will be very grateful. Your webcam, sorry. Nobody? Okay, thank you, John. Okay, thank you, Joanna and Michael. Thank you, Rob. Max, it's a bit blur, but
it's okay.
It's okay. Okay.
We like
Thank
strange
you, Claude.
inputs. We love strange inputs, in fact.
Okay. Thank you a lot. Okay, so
We are going to record video, so
Yeah.
you can move if you want, anything.
okay, so we start recording now. It's gonna be just 10 seconds. Yeah, I think it's maybe enough. 7, 8, 9, 10
Okay.
seconds. Okay.
Yeah.
Thank you. Now you can close your webcams. We'll start sharing again our computer or a screen, sorry. If I find the Zoom interface. Yeah, okay. Parlas tú, quédate con eso.
Okay. So what we are going to use now is that the first computer vision tool we use. It's an YOLO 9000. It's an object recognition tool that assigns labels to parts of the image. Okay, and it has a vocabulary of 9,000 words, and it has a really strange vocabulary, and that was what got us also interested. And we are processing,
Okay, so
trying to process.
yeah, okay. I forgot this comment. You are going to see live the comments that we are going to use. So now we are just okay.
Okay.
Now you can see the first tool that we use. It's called YOLO 9000. It's very old. Actually, I remember the first time I installed it before we had a GPU, and it took something like 7 seconds to process just one image. Now we are processing 250 images because it's something like 10 seconds at 25 frames per second. So it's very fast right now.
And if you are fast reading, you could see some strange categories that start to pop in the monitor, like bullfighter. I thought bullfighter because we are in Spain.
So now here we have the output. Okay, so some of you doesn't seem to
be persons for the
okay.
tool.
Okay.
And we have also we used also the not to have all the detections.
Okay, we can see here. You know, the frames.
And yeah, and it was this strange vocabulary that also got us interested in that. There's what you're seeing now, the last word, the last comment, threshold. This is the confidence threshold. You want to explain it? Or?
Yeah, okay. These computer vision tools you can say that they find a lot of things, but with different confidence. Okay, so they might find an object there that they say this is a computer with a 95% confidence, or I think that maybe this is a banana, but just with a 10% confidence. Okay, so we can decide how many of those detections we show on screen. And one strategy that we have used in our project is trying to lower this confidence threshold and to see its output. Okay, so we are going to process the same sequence using a lower threshold. So maybe some of you will be persons again. Okay, it's fine.
And more words of the vocabulary will appear. So we also sometimes, as a metaphor, we say that it's kind of a psychological strategy to make the tool talk and talk and talk. And also we like also the graphic output. As you will see, there will be much more labels, and that is also something that we are attracted to in a graphic or in a static sense.
Okay, it's coming out. So it's here, it's here. Yeah, now not a person, but a living thing, some of you. So getting closer. Yeah.
Yeah, and it's much more messy, and it's much more the tool speaking somehow. And then another thing we did, and we
sorry, can you open also the TXT file? Sorry, because I'm curious to see the comparison between the previous one and this one.
Yeah, anything you want to ask?
Sure. I mean, the same goes for the audience. If you want to ask anything, just like ask it on the chat room, on the chat, and we will bring it up to Estampa. So it would be nice if you could like maybe put both TXT files just to check the difference. Thank you.
Yeah.
For us, this was also a starting moment. I mean, if you'll see the 5. For instance, it says Asian, so that it appears this word. It's what we said before. Maybe this tool was not truly developed to be implemented, maybe, but it's kind of symptomatic that there's an data set of computer vision that has this label.
Yep. So
do you see something? Website, curious category. I've never seen that one before, I think.
Maybe you haven't processed
No,
screen capture.
Sure.
So
yeah.
I love instrumentality.
Yeah, there are these.
Yeah, this is because the data set comes from WordNet.
Yeah.
So it was how it's called. Okay, there's hierarchy of words. So there's also a hierarchy of things. So when it says living thing, it knows you are something that has a life, but it doesn't exactly know what kind of animal or plant or whatever you are. So instrumentality, I think it's at the top, or almost at the top. There's also organism, artifact. Artifact, it appears a lot also.
Yeah. But this is truly also what caught our eye when we started working with this. Why this word? Why? How it's possible that this word is here, or how it's possible that somebody has a data set that says these images go with instrumentality, because it's not only these problematic categories, but these other ones that are more like abstract, for instance.
And something else that it's good at having this DUI approach that Danny said before is that since you have the code on your computer, you can modify it. So we have not created neural networks, but what we have done is modify its output or process it somehow differently. And in this case, what we did with the YOLO-9000 is modify the graphical output, okay? So for instance, what we will see now is just what the neural network detects and the label. But everything that the neural network doesn't detect, it's white, okay? So this is the part of the image that the machine doesn't understand somehow. And we have used this in different projects.
Yeah, working with the graphic output, it's something that we like, and we think that it's an easy way to reveal what does the tool does. And also, in a sense, because when we started working with this, was all this discourse about computers can see. So what does it mean that a computer to see? It's a question that we asked. And with this kind of visualization, we see that seeing, for a computer to see, it's kind of a filter. So it's not understanding, in this tool, it's not understanding the whole image, but understanding excerpts of the image. And it's matiz, it's a small change maybe, but you start to understand better how these tools work. So it's like kind of small interventions in the use of the tool. And this is also something that's underlying what say Pau, it's because we have the tool here and we can work it and we can open it.
Yeah. So going back to the hard drive folder list. Okay, the next one is char RNN. This is a text generation neural network, but very old. The results are nothing comparable to the current ones like ChatGPT, BART, or GPT-4. We are not going to go into this one. The next one is Inception. Inception is an image classification neural network. In this case, we used it to classify images based on artistic style. Okay, so we train it with a data set called WikiArt, and then it learned to classify. And we also train YOLO using this data set of artistic styles. So this is the next step. At first, we were using YOLO-9000 without any modification, and with the training that came with the original code. Then we modified its output, but also we made some trainings with YOLO. So to make a training, we need a data set. So we created those data sets. Those data sets are not comparable to the ones that are being used today that have, I don't know, terabytes of data. They were really small ones because it's hard work to make them. But for us it was interesting to try to make new trainings. We'll show some of them maybe later or right now actually. Okay. Yeah, sure. Okay, so we will process the video with the art style classification and see what it says.
Wow.
Yeah.
Easy one.
Yeah, but no, I tried with another conference before and it didn't say cyber art, it said mainly pop art. Okay. So in this case, it seems more like cyber art. Let's go back to the output folder. Let's work here. Okay. No, that was not the correct command.
All live.
Yeah. Okay. Cyber art. Okay. In this case, it was really not detecting objects inside the screen, but just the wall screen, okay, just the wall image.
Yeah, and in this case, and with this kind of experiments, when we started to train object recognition or image classification with some data sets, what was also interesting for us, we kind of understood that these tools are kind of, we said that are like kind of compulsive experts, because they only see what they are trained on. So we have this tool that can classify art somehow, and somehow it works with art images, but we can use as input any image and it will relate it to an artistic style.
Yeah.
So this idea of artificial intelligence being like compulsive, it's like, we like this word, like compulsive experts. No, it's an expert, but it's compulsive. So it's not really an expert because you need to stop your compulsive thinking. Okay.
Okay, shall we go to the next folder?
Yeah.
Okay, cycle gun, laser gun, we're not going to comment on that. Warp RNN, another tech generation, all segmentation. Then the next significant ones for us is Pix2Pix. Some of you may remember it because it became somehow famous. Pix2Pix was a image transformation network. So you gave it one image and it transformed into another kind of image, okay? So to train it, you have to create a data set of pairs, the inputs and the outputs. And the typical example that always works with Pix2Pix is from drawings of cats to cat photographies, okay? So you made a drawing with just the lines and then it created a, not really photorealistic by today's standards, but at that time was, okay, that's impressive. Image, okay? So what we tried to, what we did actually with this one is work with another project of Marcel. Marcel is an animator, and at that time he made a project rotoscoping roundabouts, okay? So he recorded the whole circle of the roundabout and then rotoscopied it. We can see the data set here, okay? So for instance, this is the video.
Yeah.
And then what Marcel did was this thing, frame by frame, okay? Animators have a lot of patience. I usually automate all these things, but they like to do it. So what we did is create a data set of these pairs. So, so for instance, in this case, we have all the images. This is the first one on the realistic image one, and here we have the pair, okay? So the network learns to translate between this type of image to that type of image, okay? So then we gave it a new roundabout. I think this one was new, it was not in the training. And it did this, okay? So, okay, Marcel did it better, of course, but it's not bad. Actually, we were surprised of how good the results were. But then what we did is doing it recursively, because we trained the neural network to go from realistic image to rotoscopy, but we also train it from rotoscopy to real image, okay? So we gave it the rotoscopy that the neural network had done, and what it did was this, okay? So it's not as realistic as the original image, but it's quite okay. It has some noise, but we like it. Okay. And we also tried to apply to other kind of images, because it was only trained on roundabouts in the south of Catalonia, so just a specific type of landscape. But we tried with another one, and okay, it's not that good, but you can maybe see some things, not too much. Okay. And another experiment that we did with this tool with Pix2Pix, it's an experiment that we copied a project from another artist that what he did is train the pairs where a frame and the next frame of a video. Okay, so trying to predict the next frame of a video. So in some way, trying to predict the future. And the future doesn't look very good according to this, because this is what we got from it.
Yeah, and it's this kind of conceptual approach that other people has done also, but that we like a lot. We have this pair of images, we have this transformation. The idea is to do style, but conceptually you can say, okay, if you are learning to go from here to there, if here to there is one frame, in a sense, you are learning to predict the future, as said Pau. And it's this kind of thinking that we like, this kind of conceptual approach also to the use of the tools and to work and play, because we also think it's very playful with the metaphors and how these tools are explained to us.
And something interesting that I think is interesting to comment, that here in this hard drive, for each project or from some of the projects, we have the data set. Okay, so in this case images, in our case it was text that we used to train the image. Then we have the network. Okay, so this is the model, it's called technological terms. So the trained neural network. And we also have some of the outputs. As Danny said, we don't have the final outputs, just some temporary ones, or maybe in some cases are the final ones, but they are not very well ordered here. Okay. So these are the three parts of each project somehow.
Okay.
So actually, talking data sets, something I hadn't done before, is, for instance, look for folders called dataset inside the hard drive. Okay, so and here we can see that we have created quite a lot of data sets. Some of those ones are not ours. For instance, these ones are not ours, but a lot of others, they are ours. So it has taken a lot of time to create those data sets. We are lucky we are 5, because if not, it's hard. So we can
that was also Pix2Pix was an example of an early kind of generative tool, neural net. That's why we wanted to show you, and it's also quite simple, this idea of the pair of images and how it learns to imitate something.
Okay, so next folder, it's called Stylegan, but actually the older one, it's PCG GAN, Progressive Growing of GANs. This was the first really generative neural network that we use. And most or some of you only know about DALL-E 2, Midjourney, or Stable Diffusion, but this is quite recent, from last year and a half or something like that. Before, the generative neural network that existed could not be directed towards a specific type of image. Okay, you can train it on types of images, but then you just say, okay, generate an image, and it generated a random image from its capabilities. Okay, but you could not say, I don't know, Donald Trump skating on a bridge, something like that.
In case you have only used like Midjourney and all that, it's not a kind of prompt image generation. It's a neural net that learns to imitate some kind of image. And you can only ask for an output, and you can guide it somehow, but not through text. And are quite, and at that time, they need to be quite specific. The data set has to be some kind of image. It could not be very, very heterogeneous, the data set. Sometimes we tried with heterogeneous because we like to do things that are supposed not to do.
So we tried with different kind of images. For instance, we tried using frames from different videos, like a trip down Market Street, an old film from San Francisco.
Yeah, somehow for us, the idea is what the data set is and how to define a data set. So the data set could be defined for the kind of image, but for instance, a film could be a kind of image also for us. Okay, in this case, the data set was looking for images of Mona Lisa in Google Images. That was the conceptual idea behind the data set, and it was too heterogeneous, of course. The final output didn't look exactly like this, but we don't mind this. It's more like, conceptual approach to. And this could be also, a film. A whole film could be understood as a data set, for instance, for us.
Okay.
Yeah, this is a very well-known film by Maya Deren. And we trained a GAN in order to do a kind of remake of Maya Deren's film. It's very abstract, but if you know the film, some things remember, some things really look a bit like the film. You could see some motifs there. And also the question here always is, what is a data set somehow, and how we define a data set and how we can play with this, because for us it's also very, it's a critic, but it's also very playful working with these tools.
And another thing that we did with some data sets is try to sort them by the characteristics extracted by neural networks and using machine learning tools. Maybe some of you have heard the word TSNE. It's pronounced like that in English, I guess, or UMAP or something like that. Okay, these are tools or techniques that let you map multidimensional spaces into two-dimensional spaces, because neural networks extract a lot of characteristics of the images, and using these tools you can sort them in a 2D or 3D space. Okay, so in this case, these are not all the frames, but some of the frames of the Maya Deren dataset sorted by the neural network. Okay, and we can see here that it could close the eyes. Here there is a record. Okay, so similar images are closer together.
And sí, darrere anem un moment a Shiny perquè veurem els fakes, no?
Okay, yeah.
So, potser podem ensenyar un altre. Yeah, we do this kind of conceptual. This is called, when you generate images here, it's called a latent space exploration. So the metaphor of space is inside this kind of tools. And that's why we thought about, in this kind of collage approach, of real spaces. So here the data set were only the corridor sequences, the very well-known corridor sequences of The Shining. And it's a kind of remake of this image and of this space. It's kind of creating like a double of this space. And it looks, of course, like kind of a nightmare. Sometimes we say it like that, if it was like the computer having a nightmare after looking The Shining. But what we wanted to show you is, while the network is being trained, you can access the images that the network is producing, and you stop the training when you think that the result is good enough. So this is what's called the fakes.
Yep.
And this is how you have a peek on how the network, the training process is going on. As you saw, it started with random noise, and we are going backward.
Yep, we are going backward. Yeah.
And we have this for all the trainings we have done with this kind of net, with PGG.
Yeah, some of them I have deleted them.
Yeah. Yeah, it's a computer, not
Yeah, because
not a trash folder.
we are constantly looking for more space because the hard drives keep getting full. So sometimes we have to delete some things.
And with this neural net, we cannot generate anything because now it doesn't work in our
No.
environment. So we are going to generate some images with a different network net, but it's
Yeah.
the same idea.
Yeah, this one it's style gun 2,
Mhm.
AIDA. Okay, so
Okay. Yeah, in this case, what we are going to see are only tests. It's not an ended project. And we have, yeah, the first one we have is CRDI. It's a data set of historical portraits from a city in Catalonia, from Girona, as a photographic studio. They had they have the several archives of photographic studios in Girona, and we trained a neural net on these portraits. It's already generated?
Yeah, it's
Okay.
already generated.
Okay. Yeah,
Yeah,
perfect.
something I find interesting or that relates to what I said before. And here it says generating image for seed 0, seed 1, seed 2, etc., etc. Okay, those seeds are somehow pointers to inside this latent space that Danny was referring to, but we don't know exactly what it's there. And it's a big dimensional space. It has 512 dimensions. So it's really hard to, it's impossible to imagine actually. So we are going.
Yeah, it says latent space. If you think of a 3D space, it's like thinking of all the possible images this net can generate after being trained, and you can situate it in a space. So when we ask to generate one image, we have like the coordinates of this image, and we can recall these very same coordinates. That's what the seed is.
Yeah. What we are seeing now, it's generated images. This one is quite clear. The previous ones were okay, quite realistic because those are all portraits. Okay.
And this is also a way to, when you have a trained net, we generate a lot of seeds in order to see what kind of images this trained net generates. We know, of course, because we have used this data set, but it's really for us in working, it's kind of an exploration of every trained net. We have to learn we have to investigate, to research a bit what it has generated.
Okay. And something interesting about this latent space is that it's continuous. So it can generate images for every point in space. And when you go from one point to a closer one, the images are similar. So if you generate a lot of images closer to each other, what you get is a transition, a morphing.
A kind of morphing, yeah.
Yeah. So now we are going to generate one of these videos.
Okay. Now we are generating still images, but it's only that after that we are compiling it in a video. And the idea is you are in one seed and you are asking it to do the closer image. And we are also going from all these seeds, from one to another.
Okay.
And these are consecutive, but doesn't mean that in the space are consecutive. Okay, doesn't mean that seed 1 is very close to seed 0. It could be very far away in this conceptual space. Yeah, bueno, pero lo del PSA lo explicamos.
No.
Pero estaremos una miqueta. I ciao. Okay. Ensenya'm el vídeo, sí.
Okay, yeah, sure. And a parameter that this type of network has, it's called truncation PSI. I don't know exactly why the name is like that. But what it means is something like how close to the median image the generated images are. Okay, so if you go to the center, it's always the same image, it's the median image, but if you increase it, you get more strange images, but not only strange, because actually some things that are not seen usually in the data set, for instance, glasses or hats or some things like that, don't appear in the median images, but only on the frontiers, on the outside of the data set. Okay, so here it's the same
point in the space, but with different PSI. We are saying this seed, but we want it more close to the medium image or more strange. Okay, so we are traveling through the latent space. And also that is a way to see what kind of decisions you do when you generate images. Okay, we can explore it in different ways. And also we like this kind of generation tools. We always said that it's kind of analysis of the data set. So somehow this generative tool, it's explaining something about the original data set.
Sorry, guys, there's some question in the chat from some very curious students, I assume, who are doing some folder voyeurism and ask what is in the NASA folder.
It's secret. No, unfortunately, there's only one image.
Yeah.
And I think it's too heavy to open it now.
This is a non.
Now it's the black marble. It's a very well-known image. It's the Earth by night, and that we use it in, I don't know, for a computer vision tool. Also, we use it, and it started to labeling supernova or computer, but we didn't develop this project. It's truly an archive. What we are looking.
Actually, I think that we wanted to do something like this. In this case, what we did is the same project as before, so sorting the images of the data set. In this case, those are satellite images from Barcelona, ordered by the neural network. So we can see the sea is at the bottom and at the top, right on the top, and the trees are on the left. And this, I don't know, the Champla, it's here. So, and this is more like industrial parts, etc., etc.
Yeah.
Okay, so we wanted to do the same, I think. But
could be.
I don't know. We didn't do it. Okay.
Yeah.
So just no. So yeah. So continuing on the hard drive. Next one is Transformer LM. This one also is significant. This is an open source implementation of GPT-2. GPT-2 was the previous version of GPT-3, of course, and ChatGPT actually it's GPT 3.5. Okay, so it's 1/2 versions before current status, or 2 versions because GPT-4 is already out. And this is significant for us because we could train it. GPT-2 was closed source, but some people made their open source implementation. And also this specific version allowed us to train it on different languages than English.
Yeah.
Because the most common ones at that time use some characteristics from English that made it not unusable, but it didn't produce so good results. So in this case, we could train it in Catalan, that it's our main language, or maybe Spanish.
Yeah, so that's why also it's important to have a do-it-yourself approach and that tools are open.
Yeah. So we train it. We tried with a lot of different styles. For instance, we tried with legal documents.
Yeah.
So it said some boring things. We tried with a dictionary with all the definitions of the Catalan dictionary.
Yeah, and now we have a tool that can define any word we say and any word that we invent, or that they can change the meaning of things somehow.
Yeah. We tried to train it in chess games.
Yeah.
Notation of chess games. So it learned to play chess not by learning the rules, but by learning typical moves, but from the text. We tried with the horoscope to generate new names.
Sometimes also we mix things, because we did one with the horoscope that was for another project, and with macroeconomics projection. So it was like mixing two kind of styles of writing. And it was also, of course, a mockery on this idea of prediction and artificial intelligence. And this idea of working with specific data sets and doing kind of experiments. Yeah, and that's what we like to do also. And that's something that you cannot do with GPT-3 or GPT-2, or well, with GPT-3, which is pre-trained.
Yeah, you can
Fine a bit.
Yeah, with the prompt, but it's not exactly the same. We only have one training in English.
Yeah.
In Catalan or Spanish. So we're going to generate with this one. This one is trained on.
Yeah, the data set were the terms and conditions of social media.
Yeah.
So we constructed a data set with Facebook, Instagram, TikTok. And of course, the idea is this mockery of the babbling, no language as a babbling a bit, no? Babbling is the word?
Yeah, babbling is the word, yeah.
Okay.
Or chatter, something like that.
Okay.
We had to look it up before.
Yeah.
Okay. So in this case, we are somehow giving it a title, Privacy Policy Skinwalks Artist Talk. And we'll see what we get. We can make the text bigger. If some of you have problems reading, just ask us, okay?
Yeah, in a way, this opaqueness of this kind of legal language, it's something that the tool learn it to reproduce. Okay, and we can give it context, or we can ask for how to start the text.
Yes, in this case, we are going to ask to start with participants should know that the purchase, the wall or Switzerland, okay, very appropriate. These terms of use apply to you, provide activities that are responsible for any request or the world, or individuals around the world, or the Facebook, you and only. Okay, so we cannot understand either
the original terms and conditions
so
didn't want
it's not
to be understood.
Too dissimilar.
Okay.
Okay, so going back to the main folder list, we have another project that's interesting. This one, this one, yes. Okay, this one, it's when we use different type of computer vision algorithm to process images and make some editing. So then it's going to explode.
Yeah, here we have only outputs. What we are going to do is process again the video, and we are using here different computer vision tools. We use it for a project that we entitled it Host Images, and also it's a title that we like a lot. It's host images in the sense of parasites. It's the idea of artificial vision of being kind of parasite of images. So images today are host images, but because there are a lot of things happening in images and a lot of data which is extracted. And we use different computer vision tools, and it's also altering a bit the graphic output, and it's kind of trying to focus on each computer vision tool and what it does.
It's taking longer than expected. It says 2 minutes. It should
now, which one are you using now? YOLO.
No, AlphaPose.
Okay.
Okay, but we can check the output while it's processing. So do you want to? Okay. But it's 1 minute.
Okay. We want to entertain you. We are going to our website.
Yeah, we're going to our website. Okay.
Yeah. And
There you go.
Yeah, it was projected as not as a multi-screen, but with several screens. And the idea is we have one input and it's processed with different tools. And the idea is also that these different tools doesn't reconstruct the image. each one sees one particular thing. This one is the one we are processing now. It's the posture. This one is object segmentation. This one is trying to infer the profundity, the depth, sorry. And this one is YOLO 9000 that you saw before.
Yeah. Okay, so it has been processed. So let's check it out. Yeah. Because okay, I'm gonna close it. I'm gonna open it later.
La profundità.
Okay.
Trigonamente, no?
Yeah. And it's cool. Okay, it was just a C left.
Aquesta segmentation, no?
Sí.
El de profunditat.
Però està la més aquest de mi.
El de profunditat, trigonament?
Sí.
Vale, okay. Sorry.
Okay, so if you go to the output folder, we should find okay, it actually this one, but now we don't want to open it with media input. Okay. Now
it's the same idea as before, that we like to manipulate the graphic output. Usually it will show you the image under the original input. It's of course a very easy operation, but we think it's a very easy operation that helps you to focus on what the tool is doing. So that's why we tend to manipulate graphic outputs of computer vision tools. And we really like also some of the aesthetic of this graphic outputs.
Okay. It's 1 minute and a half left. Maybe we should try with a shorter video. Yep. Shall we?
Quina és aquesta de segmentació?
Yeah, this is segmentation. Okay.
Yeah, we like the idea also when we presented this as an installation, there are several screens. There's not the original input. And we like this idea that several tools do not reconstruct the original image. So computer vision tool, it's kind of a filter. Computers see, but see specific things. And also about computer vision, what we also say usually is that also computer vision doesn't look to the world, but look images of the world, which is a bit different. And also it helps to put contemporary tools in a historical perspective. So it's something that it's being added to our visual culture and to our visual technologies.
It's just 50 seconds. Something else to say.
Do you know why it's taking longer in this case? What's the reason why it might take longer?
I don't know. I tested with 10 seconds video, the same resolution that I was checking before. I don't know.
Maybe because we are streaming and the GPU it's more
I don't know.
But
so,
that is also interesting. Now we are checking with excerpts, but every time we work with this, we have this this time span of processing, generating.
Yeah, I'm gonna put next thing and start because it's gonna take so now.
No can enseñarlo él solo.
Oh no, the next okay. No, not this one, but because I forgot.
Okay.
Yeah.
Okay.
No.
Sí.
Yeah. Yeah. So this one maybe. Oh, sorry. So I'm gonna delete this folder and put it again. So there should be a folder called segmentation here, but I don't see it. So I don't know where the output from the previous command went. Okay, so okay, the problem is that the folder was not created beforehand, so it didn't write the output.
Okay.
But
We are generating something. It's the last thing we are going to generate, and then we just check maybe 2 folders, and we will do kind of this interactive searching inside the computer.
yeah, okay.
Okay.
So we are going to go faster now through the
And
folders. What? Yeah, but it's going to take a bit.
Okay. We are processing.
Yeah, we're
Okay.
processing. Something that we also used to do, it's not only use one tool for one task, but chain different tools. Okay, so what we're doing in this case, it's removing people from the image, okay, and using something like the content aware fill, like in Photoshop, to remove the people. But first we have to detect the people and make a mask of them. Okay, so we use a neural network to detect the people, then we make the mask bigger, then we remove the people with another neural network. Okay, because sometimes they say that they do a lot of things, but usually neural network tools do just one thing, one task.
Mhm.
Okay, so going back to the hard drive, we have, yeah, sure, okay.
Here also what Paul says is the thing we are doing here, we could do it with Photoshop, but using neural nets, we can automate it and we can escalate it. And the project was we use this for an exhibition. The idea was to do a kind of intervention in social media, and an exhibition, all the documentation of the exhibition and all the social media was like the image on the right. Okay, so it was kind of producing these images where everyone is anonymized, but it's anonymized in an automated way. If the tool doesn't detect you as a person, for instance, you are not anonymized, sorry, or however you say it.
Okay, let's see how it's going. Okay, so have to wait a bit more.
Okay, enseñame algún vídeo, ¿no?
Yeah.
This exhibition was about it was called anti-biography. So this idea of anonymization was quite important in the exhibition. And all the public images of this exhibition were like that. Our action was a bit an action in social media and in the documentation of the exhibition.
Actually, this exhibition is going
Yeah.
on tour in Catalonia. So if you are here,
Yeah.
maybe you can check it out. It's gone anti-biography. It's going to be in Mataró.
Yeah, in several series.
Yeah.
There's another question from the chat asking, what neural network did you use to detect people in images?
Oh, actually, I don't remember in this case, but I'm gonna check. Yeah, but I have used different ones, but I don't remember. I'm gonna check. So going to home.
It was a segmentation tool because there are different,
Yeah.
It was not like YOLO because it's not a bounding box. You have to segment the body.
So
and also in this project, what we did was that people have to sign a terms and condition accepting to being erased on all the images. So they gave us permission to us to have their erased image. And the document was, somehow a mockery of these terms and conditions. And entering the exhibition, you have a text saying that if you enter there, you give us permission to record your erased image for the eternity, more or less. And this was kind of translating a poster that was in Apple Store, saying that when you enter there, you grant them permission to use your image whenever they want.
I'm not able to find it. Okay. Body pics. Body pics, it's quite old actually, but it works for, I don't know, or Deep Lab, I don't know. I guess one of the two. Deep Lab is even older than Body pics. Okay, so it has generated the output. So we'll see. I have to copy it to the corresponding folder. So now let's go to data again. Okay, it detected correctly all of you this one, so you are absent from the images.
Yeah. Okay, so
okay, now we are okay. This image generation, analysis, text generation. This was processing my time, terms and conditions. This one, it's one project that we are proud of. It was for CCCB in Barcelona. It was image generation. So we trained a neural network with a big data set. It was 25,000 images or of illustrations of different kind of animals or plants. Okay, and we created this data set. It was really hard. And something significant also is that only now in 2022, stable diffusion appears on the radar. Okay, so this case is outputs that were in the home folder, but it was full, so we have to move it here. It's nothing important. Okay, so more projects, stable diffusion. This is one project that we are working on that we're going to present in a literature festival in Barcelona in 1 month or something like that. And I think we have finished.
Yeah, maybe we can do, we wanted to do that we have used a computer vision tool that we have not trained, but has seen all the images in this data hard drive.
Yep.
Now it's scrolling on.
Yeah, we are going to see how much energy we have used in the last hour in this computer. Okay, so okay, 0.9 kilowatts. So not.
We look to Mark because he's he's the expert on.
It's okay.
Yeah, it's quite standard.
Okay.
I think.
Okay.
You get Mark's role in the collective to come in and just like say, "Hey guys, stop with the energy now. It's too much."
Yeah. Enough is enough. Stop playing.
I'm here behind just to control.
Okay, so as Daniel have said, we have processed all the 600,000 images in this hard drive using maybe some of you know it. It's called a neural network called CLIP. It's used in DALL-E 2 or in stable diffusion. And it's very interesting what it does because it maps images and text to the same multidimensional space. Okay, so if you say the sentence "a horse," it will go closer to a picture of a horse, but far away from a picture of a car, for instance. Okay, so you can look in this multidimensional space using images or using words. So in this case, we have processed all the images, and then we will ask for images that are closer to some sentences. Okay, we are going to start with something easy like a street. Okay, and we want you to think some sentences that you want to use to search inside our hard drive. Okay, so this image it's a street. Okay, we can see that this network can read. Okay, but this is okay, it's a street, but
it has been trained on images and on the image caption. So it could be also that in this image, of course, in the image caption was the word street.
Yeah, no, that's what we
No?
showed before. But
Ah,
this
okay.
image is on our
Yeah.
folder.
No,
but
but
it doesn't
no,
have a
of course,
caption.
of course. But in the training,
Yeah.
that there are
Yeah,
images
okay.
that the caption I mean, it's not reading.
Yeah, of course. Yeah. It's not really
Great.
good. Yeah. Good.
Great. We have this kind of discussion also.
Yeah.
It's kind of a family thing.
Okay, no postcard from Barcelona.
Mhm.
More streets. We are not really sure what is this one. We can see here at the bottom the path,
folder.
the
Yeah.
folder, so we can understand what it is. So in this case, it's just something that we process with pix to
With
pix.
to pick, yeah. I think it was a street.
Probably. Okay, no postcard, more streets. Okay. This one it's easy. Okay. There are more, but we have limited to between 10 and 20 images. We can ask also for novelty.
Yeah,
What-
the idea here is that this is not a computer vision tool that has been trained with the data set were images and image caption. So we can introduce not only object recognition, but this kind of concepts like novelty, for instance.
Yeah.
Okay, and doing this, we are also interrogating the tool somehow. That's what's interesting for us.
It's not very novel, actually.
It was.
It
It
was.
was.
Yes.
There's someone asking on the chat if they missed which model is running now. Is it Clip? Is it a trained, fine-tuned?
It's actually it's open clip. It's an open version trained on the Lion data set. That is the data set that is being used to train a stable diffusion also.
Mhm.
And
I just want to remind to everyone, if you want them to search any word on the model, just write it down on the chat and we will bring them.
Yeah.
yeah, we can see the chat. I think we can see the chat.
Yeah.
Okay, Daniel will see it here.
What's international?
Yeah? Okay.
We are seeing the chat now, sorry.
Okay.
But we ask, you told us.
Okay.
But yeah, what you do want to search? Artificial?
No. Sorry. No.
Yeah.
As Danny was saying, we are interrogating data set, so we see the kind of images that it get out. So I mean, it's please no.
Can you search a classic for Mark and myself? Can you search underwater photography, please?
Underwater
Yeah,
photography.
Sure. Oh, it's right. Yeah. Okay. It may be. Yeah. No, really, but has some blue in it. Okay, there's water, it's not underwater.
Sort of.
Yeah, this one yet.
Yeah.
Yes. I might remember. Yes. No.
But
Okay, this is from Design Hub. This trends. Yeah, this. Right. It's interesting. This one. Okay. Yes. Okay. This is a segmented image. Okay. So what else?
any ideas?
It was instrumental, no? Before the word that popped up.
Instrumentality.
Label.
Instrumentality, yeah.
Instrumentality.
Okay. Anti-asmático.
It goes back. Paul, it's another interesting word.
I guess it was too easy for it as instrumentality already pops up a lot as a synset within ImageNet, no? So the model like finds it easily.
Screen wall. Okay.
Okay,
Something, yeah. Sure.
you can ask for something. Okay, we don't want to see because we're going to see. Those are masks from an intermediate process.
Yeah.
I don't know why we don't want to see them, but that's what the machine thinks. Well, not the machine is.
I guess it identifies like the mask as masking something, no? It's like obscuring and trying to hide something.
Very
Yeah.
interesting. And this one, almost nothing to see. Okay, that was it. Any ideas?
Que busquemos alguna.
Okay.
You were about to search for a skin walk too, no?
Yeah.
The screen works. We see in the chat that somebody asked if it's clip.
Yeah, no,
That was already answered. Okay, there were some errors on the terminal, but this was a failed training, trying to mix images from real worlds and video games, but it was too heterogeneous, as Danny said. And it's
Was this part of a folder titled Videojoc Realitat?
Videojoc
Yes.
realidad.
Because there's another folder wire here, Marco, who saw that folder before and was quite curious to know about it.
yeah,
Yeah. It was it was its training. Yeah.
Can you explain us a little bit about that?
Okay. It was said very fast. It's a GAN that we trained with a data set. It was with this kind of computer games, point of view computer games of firing, no? Of shooting.
First-person shooter.
Yeah, first-person shooter, and also helmet cams in real warfare or in training. So it was trying to mix these both iconographies.
This is the video. Okay, you see, there is the video game at the start and the real images in the back.
And why didn't you pursue it? Why did you like stop?
Oh,
working on
we
it?
have it in our website. It's one of the experiments we did with guns. Yeah.
Okay.
It was kind of an abstract imagery, but yeah.
Just that, okay, it was failed because the final images were not really similar to the dataset ones. Okay. Try to see if the neural network will mix both type of images, but it didn't. So, okay, I think it's somewhere. It's here. Okay, so those are screen works. This one is interesting. More works. Okay.
Yeah.
That's the end. So,
and I don't know, we did some test also with this tool, and for instance, maybe we just explain. No, we try to look for the best image, and then we change it to. We know that you don't say that maybe in English, but we said the prettiest image, and when we use prettiest image, there was a gender kind of image that appeared. No, it was more like kind of female. So that's what we we say that every time we search, every time we use a prompt, we are producing something, but also we think you have to think that you are interrogating a tool somehow. This relation between the prompt and what is the output, it's something that we think it's very interesting, and that now we can be very aware of this. And when it will become a very, very common tool, maybe this relation will be something that we won't be as aware as now. So now the moment to be aware of all that, because it's more obvious for us. It's not that natural. And that's why also we are happy that we started working with this when the technologies were smaller, because some things we think that you could be more aware in this at the beginning somehow of things.
And it's not only maybe awareness, it's also like the possibility of accessing both the hardware and the software, I guess, no? Because of like the tools that you need to train current generative image models are not accessible for many, for most, I would say, while like previous technologies and previous models were still difficult to access, and you need like some expertise, no? But you still can work with them.
Yeah, I mean, we were just talking about, right, John, these costs of training Stable Diffusion that were just released. It was like in the hundreds of thousands. So yeah, unless you're a millionaire now, it's very hard to think that you can actually train such a large data set. No, it was interesting to see actually also, yeah, through your folder and the history going from tools that you could build yourself, you know, even just going from like ChatGPT 2 to ChatGPT 3. Like so many of these things kind of changed, no?
Yeah, and also for me, quite interesting to see is I guess that's because at the Photographers Gallery we did a whole program on datasets, and we got quite a lot on datasets. And all your ideas of thinking of a film as a dataset. For instance, that's an example, but we often run with Marco, we've also talked about this, like thinking on the collection of the museum, particularly given that both the Photographers Gallery and Photo Museum Winterthur are photography museums. Thinking on the collections and as data sets is also an interesting idea. No? You did something like that with an archive, but an archive has its own specificities. Have you ever worked with a private collection to do that? I've seen other museums doing it, but I'm not sure if you've had any opportunity to do something like that.
With a private collection,
Yeah,
with some museums with indeed, an image classification tool. We train it on the collections of the main museums in Barcelona, MACBA, Contemporary Art Museum, and Design Hub, and Tapies. And that we work it with these collections. It was more classification. It was a data set of the art institutions in Barcelona. And of course, the collection was very heterogeneous also. And also thinking about data sets, what we, from the beginning also started to do is, we know that we need a large amount of images, but we need that for industrial purposes, or we need that for producing realistic images. But for us, we did experiments with
smaller
poor data sets, if you want to say it like that. Okay, so the idea that, okay, there are industrial standards, but this doesn't mean that you cannot use the tool in a different way, and it can be interesting.
Yeah.
I guess that one of the questions will be like, the bigger the data set, the more photorealistic the output.
Yeah, and the bigger and the more homogeneous. Of course, there are different.
It's a combination of both.
But in this case, it was the historical images of the archive in Barcelona, the photography archive. That was the original data set. It's very heterogeneous, and it's only just 500, 200?
No, 500, between 500 and 600.
500 images, but very, very heterogeneous. And enseñamos algún resultado.
Yeah.
And the results were quite abstract, Aspetta, l'immagine fixa meglio che sopra.
I love that part of the screen is encrypted in Catalan.
Ahora puțin corregut. Okay, yeah. So the results were abstract. We were not surprised that the results were abstract. For us, it's not a problem. In the exhibition was quite interesting because you saw this as a postcard, and from far away, it looked realistic. So it was beautiful in the space because it was only when you went close to the image that you could see that were not realistic. So that was also interesting.
Yeah, that's another thing that maybe to consider, and that was interesting of this scheme, well, to be able to see all these aesthetics of early guns that nowadays are sort of disappearing. Yeah, we're joking about like gunstalgia already, about like how Hassan sort of like a nostalgia of these aesthetics, and maybe beyond the joke, it's also interesting because they sort of like help us understand how they are made, you know? And that's something that with the photorealistic or hyper-realistic models, we are not able to see anymore.
Actually, one thing coming from photography institutions and looking at this from the photography point of view, what is interesting to see is that we see appearance of photography or photorealism, right? Like it's almost like all this, like the technology and the software and the processes disappear over time. All the glitches are kind of ironed out. But what comes out is like the analog photography, right? Like it comes out like this kind of the older medium, you know what I mean? Like the further we go into the future, the older the medium looks like. It looks like more like analog photography, which I guess is one of the purposes of photorealism.
Okay,
It's kind of interesting that we have this kind of paradoxical trajectory, you know? The technology gets more and more up to date and cutting edge, but the visuals are getting more and more like it was before, optical, I guess.
Yeah. No, and related to this, come on, Emma, Barrera, with these images. Oh, oops, sorry. Alguna dell'ultimo segno. No, that we think that even if they are abstract, they say something about the data set and something that we can see in the data set when we look to the archive. But this kind of image, this trained network, return it to us a lot. And it says it's kind of an image of the power, how the power of the 70s in Barcelona self-represented and the gender of this power. And also, again, it's kind of, you can look at it as a proposition because it's kind of a mockery of this power. No, it's like a caricature, even with only eye, no, with this cyclopean eye.
Yeah, maybe also like sort of blurring the details and the specifics of who this person was, but focusing on more general conceptions on the image of like as gender or power, as you mentioned, in some way also to understand like from a broader point of view, no? Like a whole data set, instead of focusing on the details of each of the images. So like zooming out, no? and looking at it across.
Yeah. It's that exactly. And that we don't need these realistic aesthetics. And we already knew that the images will be like that, but we think it's interesting.
And actually, now in more recent project, how do you go about the creation of data sets? Because as we've seen, this like Lion 5P, you know, data set for stable diffusion that you mentioned, it looks like, you know, there was this time that John and I were saying that we're nostalgic about, where you can craft your own data set, and you're also saying like how much time it goes into making your own data set. Is that still possible? Is that still a thing? Are you doing it in your artistic practice, or are you now working more with Lion 5P and working with existing data set?
We are still doing it in this project, the literary project. We are constructing our own data sets. And also we think also more or less, no, that is something that it's open. I mean, these tools, you can still use it today. The fact that there are some supposedly state-of-the-art new neural nets doesn't mean that you cannot use. I mean, for instance, we really like experimental cinema. And experimental cinema somehow is saying like, oh, okay, I prefer 16 millimeters than 35 millimeters, no, because I can work with that. So that's this kind of.
Yep.
To
At the same time, these tools, like I think you mentioned, some of the tools broke, right, in the past. So
yeah, one actually from the ones that we tried, just one broke, but I'm sure that more are broken, but we have not tried them.
Yeah.
But,
I mean, just in terms of like, maybe that's also a bit of a difference, right? With like a 60 millimeter film, or like how much corporations are still driving this technology to a way that even if you want as an artist to kind of like uphold a certain, to use a certain technology, how, I just wonder like how feasible, how easy it is to do it.
yeah, actually we have not trained image generation neural networks recently.
Okay.
No? So in this aspect, it's I agree partly with you. It's becoming more difficult because everything can be generated. So it's complex. I don't know. We tried with some dream booth. Maybe you know the techniques. So you can put some objects inside stable diffusion, but not as an artistic practice, more for other things. But yeah, for another project that we are going to do, we'll have to create a data set for segmentation, or object detection. And in this case, of course, we are going to reuse existing data sets and filter them, because it's impossible to. In this case, it's not just selecting images, but also making the mask, drawing the mask of the object that you want to detect, or the box.
So even the accessibility of like the old models is quite like for a regular like artist, let's say, or like a regular like a person, is quite difficult now, because labeling all those images in the case, for instance, of segmentation, takes so much time and so much work that it becomes like a never-ending task. You know, so it's like, I guess that's one of the things to take into account when we interact with these tools. No, how accessible or not they are. No? What kind of relationship we can build with them.
Yeah.
Okay, so maybe, I don't know, I feel like we've already asked you a lot to share, and you've been super generous, showing a lot of your work and the insights of your computer, and not even like folders that we could like pick from the screen. And
Thank you much for putting up with our voyeurism of your folders and taking us through the inside of the machine.
Yeah.
And also thanks a lot to the audience and to everybody who came today to join us back in Zoom for the first ScreenWalks of the season, in a way.
Yeah, it was the first one after the ScreenWalks weekend we had at the Photographers Gallery in London. So yeah, thank you, Estampa. Thank you so much. It's been super interesting. And thank you to the audience.
We're back in 2 weeks with Aidan Walkers, who's gonna take us through some of the best memes that have made the history of network images and poor images and meme culture. So please come back.